Welcome back, students, to the second part of our discussions in the chapter of sources of energy, and today we'll be studying about petroleum and natural gas. Let's briefly recapitulate what we had studied in a previous session. We had studied that energy sources can be classified into renewable and non-renewable. Renewable, which are the inexhaustible sources, while non-renewable, those are the exhaustible sources. Talking about the conventional and non-conventional sources of energy, further we had seen that in the conventional sources of energy we include the fossil fuels, firewood and nuclear energy that is obtained through nuclear fission and nuclear fusion, and in non-conventional sources of energy we include hydroelectric energy, biomass energy, wind energy, solar energy, geothermal energy, tidal energy and OTC, that is ocean thermal energy conversion. Now, we had also discussed in a bit more detail about the formation of fossil fuels and the different types of fossil fuels that we put to use, primarily coal, petroleum, and natural gas. The previous session was actually dedicated to the basic use of coal, how it is formed, and what purpose it is used for, that we had studied. So, now we shall begin discussing about petroleum and natural gas. You can see that we have the major reserves of petroleum in different regions, as you can spot in the map. These are the major producing areas of petroleum. I will just zoom in the map for you so that it becomes pretty much clear for you. So these are the regions having the deposits of petroleum, or what is referred to as crude oil. So now petroleum and natural gas formation. Talking about petroleum, it's a naturally occurring yellowish black liquid found in geological formations beneath the Earth's surface. It is commonly refined into various types of fuels. Components of petroleum can be separated using a technique called fractional distillation that we'll be discussing in a bit more detail. It is separation of a liquid mixture into fractions differing in boiling point by means of distillation, typically using a fractionating column. Now, petroleum consists of naturally occurring hydrocarbons of various molecular weights and may contain miscellaneous organic compounds. The name petroleum covers both naturally occurring unprocessed crude oil and petroleum products that are made up of refined crude oil. A fossil fuel petroleum is formed when large quantities of dead organisms, mostly zooplankton and algae, are buried underneath sedimentary rock and subjected to both intense heat and pressure. So vast amounts of the remains of zooplankton and algae settled to sea or lake bottoms where they were covered in stagnant water, that is water with no dissolved oxygen or sediment such as mud and silt, faster than they could decompose aerobically. Approximately 1 meter below this sediment or water, oxygen concentration was low, below 0.1 milligram per liter, and anoxic conditions existed. So temperatures also remained constant. As further layers settled to the sea or lake bed, intense heat and pressure built up in the lower regions. Now, this process caused the organic matter to change first into a waxy material known as kerosene. Okay, found in various oil shales around the world, and then with more heat into liquid and gaseous hydrocarbons via a process known as catagenesis. Formation of petroleum occurs from hydrocarbon pyrolysis in a variety of mainly endothermic reactions at high temperature or pressure or both. Okay. So in the absence of plentiful oxygen, aerobic bacteria were prevented from decaying the organic matter after it was buried under a layer of sediment or water. However, anaerobic bacteria were able to reduce sulfates and nitrates among the matter to hydrogen sulfide and nitrogen respectively by using the matter as a source for other reactants. Now, due to such anaerobic bacteria, at first this matter began to break apart mostly by hydrolysis, where hydrolyzed to simple sugars and amino acids respectively. So these were further anaerobically oxidized at an accelerated rate by the enzymes of the bacteria. The anaerobic decay products of amino acids, monosaccharides, phenols, and aldehydes combine to fulvic acids. Fats and waxes were not extensively hydrolyzed under these mild conditions. So kerogen formation continued to a depth of about 1 kilometer from the Earth's surface, where temperatures may reach around 50 degrees Celsius. So kerogen formation represents a halfway point between organic matter and fossil fuels. Like kerogen can be exposed to oxygen, oxidize, and thus be lost, or it could be buried deeper inside the earth crust and be subjected to conditions which allow it to slowly transform into fossil fuels like petroleum. So this happens through catagenesis, in which the reactions are mostly radical rearrangements of kerogen. So these reactions took thousands to millions of years and no external reactants were involved. The radical nature of these reactions, kerogen reacted toward two classes of products. Geologists often refer to the temperature range in which oil forms as an oil window. Below the minimum temperature, oil remains trapped in the form of kerogen. Above the maximum temperature, the oil is converted to natural gas through the process of thermal cracking. Sometimes oil formed at extreme depths may migrate and become trapped at a much shallower level. Now, one such example is the Athabasca oil sands. Now, talking about the reservoirs, three conditions must be present for oil reservoirs to form: a source rock rich in hydrocarbon material buried deeply enough for subterranean heat to cook it into oil, a porous and permeable reservoir rock where it can accumulate, and a cap rock, that is a seal or other mechanism to prevent the oil from escaping to the surface. Within these reservoirs, fluids will typically organize themselves into like a three-layer cake, with a layer of water below the oil layer and a layer of gas above it. Although the different layers vary in size between reservoirs, because most hydrocarbons are less dense than rock or water, they often migrate upward through adjacent rock layers until either reaching the surface or becoming trapped within porous rocks by impermeable rocks above. However, the process is influenced by underground water flows, causing oil to migrate hundreds of kilometers horizontally or even short distances downward before becoming trapped in a reservoir. When hydrocarbons are concentrated in a trap, an oil field is formed from which the liquid can be extracted by drilling and pumping. Once the crude oil has been extracted, it needs to be refined, because crude oil is a mixture of several components, and every single component together make it not that useful. So that has to be, those components need to be separated, and for that a special technique is employed, and that technique is called fractional distillation, in which we make use of a fractionating column. The principle behind refining technique that is being employed is that the different components that are mixed in crude oil, they are having a mild difference in the boiling point. So that particular property is being utilized in fractionating column, and in this manner we obtain several important products that are otherwise mixed up in crude oil. So this is the basic setup of a fractionating column, in which we eventually get several products. Now, the primary end products produced in petroleum refining may be grouped into four categories. You have light distillates, you have middle distillates, heavy distillates, and others. So, amongst the light distillates, we have the C1 and C2 components: liquefied petroleum gas, light naphtha, gasoline, that is petrol, and heavy naphtha. Among the middle distillates, we have kerosene, automotive and railroad diesel fuels, residential heating fuel, and other light fuel oils. In the heavy distillates, we have heavy fuel oils, wax, lubricating oils, and asphalt. And then we also get ultimately coke, that is similar to coal, and molten sulfur. Now let me just zoom in the picture so that you may observe that the different components that have been marked here are obtained at different temperatures. So you can see at 20 degrees Celsius you get C1 to C4, that is gases, and then that is the liquefied petroleum gas. From C5 to C9, that is naphtha. At 70 degrees Celsius you get the chemicals. Then you get petrol at 120 degrees Celsius, that's the petrol for vehicles. Then you get kerosene and paraffin oil at 170 degrees Celsius, that may be further used for jet fuel, paraffin for heating. Then at 270 degrees Celsius you get the diesel oil, that is the diesel fuels. Then you get lubricating oil, which is the lubricating oils, waxes, and polishes. Then you get the fuel oil at 600 degrees Celsius. This is the fuels for ship and industrial processes. And ultimately, the C70 or greater than C70 residue that is used as bitumen for roads and roofing. So these are the several components that are obtained through the fractional distillation, and the method is obviously called refining of petroleum. Now I would also like to show you the map and zooming it for you so that you can have a look at the important sites where we are having the refineries, the oil refineries in India. Now let us discuss a little bit about natural gas. I told you that the location in which crude oil is found, exactly in the same location natural gas is also found. In fact, natural gas is found trapped above the oil. Being lighter than oil, obviously it is trapped above, and when crude oil is being pumped out through drilling or pumping, then natural gas is also obtained. So it's a naturally occurring hydrocarbon gas mixture consisting primarily of methane, but commonly including varying amounts of other higher alkanes and sometimes a small percentage of carbon dioxide, nitrogen, hydrogen sulfide, or helium. It is formed when layers of decomposing plant and animal matter are exposed to intense heat and pressure under the surface of the earth over millions of years. The energy that the plants originally obtained from the sun is stored in the form of chemical bonds in the gas. Natural gas is certainly non-renewable hydrocarbon used as a source of energy for heating, cooking, and electricity generation. It is also used as a fuel for vehicles and as a chemical feedstock in the manufacture of plastics and other commercially important organic chemicals. So these are some of the important uses of natural gas. Now, what I would also like to mention at this point that natural gas has an effect on climate change. It is a greenhouse gas itself and creates carbon dioxide during oxidation. Natural gas can be used in place of coal, for example, to generate electricity, which may lower net carbon dioxide emissions in absence of carbon capture. Because of its low density, it is not easy to store natural gas or to transport it by vehicle. Natural gas pipelines are impractical across oceans since the gas needs to be cooled down and compressed as the friction in the pipeline causes the gas to heat up. So we are having many existing pipelines in America are close to reaching their capacity, prompting some like the large trade cost implies that natural gas markets are globally much less integrated, causing significant price differences across countries. So we have LNG and we have CNG. So LNG carriers transport liquefied natural gas across oceans, while tank trucks can carry liquefied or compressed natural gas over shorter distances. CNG is usually transported at high pressure, typically above 200 bar. And compressors and decompression equipment are less capital intensive and may be economical in smaller unit sizes than liquefaction or regasification plants. Talking about pollution caused by fossil fuels. So at present, we are largely dependent on fossil fuels for most of our energy requirements. However, the fossil fuels are non-renewable sources of energy, and if we continue consuming these as at present, we may soon run out of energy. So, being non-renewable, the burning of fossil fuels causes a lot of pollution in the environment. The burning of fossil fuels, especially coal, produces smoke which pollutes the air. The burning of fossil fuels produces acidic gases like sulfur dioxide and nitrogen oxide. So these acidic oxides lead to an acid rain which adversely affects our water and soil resources. Acid rain also affects monuments and buildings. The burning of fossil fuel produces carbon dioxide gas. The presence of increasing amount of carbon dioxide gas in the atmosphere is causing increased greenhouse effect and is leading to the global warming, which is causing a lot of environmental and ecological problems. The burning of fossil fuels also produces carbon monoxide gas, which is poisonous in nature. The burning of coal leaves behind a lot of ash. Tiny particles of ash, commonly known as fly ash, present in atmosphere cause air pollution. So, reduction of pollution caused by burning of fossil fuels, that is very important. So, the pollution caused by burning fossil fuels can be reduced to some extent by following some simple steps, like the efficiency of the combustion process of fossil fuel should be increased. Various techniques should be applied to reduce the escape of harmful gases and ashes into the surroundings. The best method to reduce pollution caused by burning of fossil fuels is to generate electricity by utilizing the heat energy produced by the combustion of fossil fuels in efficient thermal power plants. This electricity can be utilized in houses and factories as the source of energy.